Good afternoon, everybody. This is the first presentation about excavators. This one will discuss backhoes and front. So, hydraulic excavators, mainly backhoes, front shovels, and backhoes. The main difference between the two is the orientation of the bucket relative to the arm and the boom. For the front shovel, from its name, it's excavating in the front. The backhoe is excavating towards the back. And that major difference will make a difference in the approach of the height and depth of excavations. So shovels could reach higher altitudes while excavating. However, backhoes could reach deeper locations. But from this diagram on the right hand side for the hydraulic hoe, you notice something very important, which is that the hoe uh, could be a little bit risky while excavating because it could excavate beneath it actually. So you must be very cautious when dealing with its safety issues, and we will discuss this in detail. So as we mentioned, front shovels are more ideal in higher altitudes and higher while excavating at higher points. However, not higher altitudes, I mean higher points higher than the level of the front shovel itself. However, the backhoe, they are more ideal in excavating deeper locations. So the thing in common between them is that you will always have what we call the bucket fill factor. So typically, ideally, you have the bucket capacity. There are two capacities as mentioned before for scrapers. One called the heat capacity and the other is called the struck capacity. The headed capacity or the heat capacity is maybe 15% more than the struck capacity. And due to this difference, and this is based on an assumption of a 1-to-1 angle of repose, a 45 degrees angle of repose. So based on that, you'll find the bucket fill factors vary depending on the type of the material. And that's not the only thing that will make the difference, the angle of repose, also the fragmentation of the material itself. So for sure, the situation will differ for rocks rather than earth, rather than clay, rather than sand. And this issue will also get affected by the technique of the excavation. This is why backhoes, for example, for rocks, their bucket fill factor are less than these four front shovels. This is because we are mainly talking about something that's having a high probability of dropping if the uh, 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 the technique itself loses the causes losses in the material that you are carrying. So the probability of having losses for rock while using a backhoe is higher than while using a front shovel. Of course, the productivity factors, mainly the class of the material, the height of cut, angle of swing, operator skill, condition of shovel, hauling unit exchange, size of hauling units. By hauling units, we mean the trucks mainly that will carry that stuff, the handling of oversized material, and cleaning up of loading area. And the one thing in common between the front shovel and the backhoe is that they do the excavation job while standing at their place, and then they they rotate about the vertical axis in order to dump into the hauling units, the trucks. So due to that, they have a lot of things in common. So the cycle time, which is mainly loading, swinging, dumping, and swinging back, it's very similar for both of them. However, the little details will make a difference. So mainly you will have the bucket capacity in loose units for sure. You will have the bucket fill factor based on the table that we have discussed. You will have the cycle time based on the cycle times that we have mentioned. and we're showing more details about them, and the efficiency factor. And of course, depending on the units that you will get, you will find how will be the units that you need, whether it's bank units, weight. Depending on the issue, you'll apply a factor to convert the units. So this is depending on that issue. However, if it is loose units, if you need it in loose units, you will not apply any conversion in such a case. So this is our equation. Again, this is the typical equation for any productivity. You have the capacity in the numerator, you have the bucket fill factor in the numerator, and then you have the adjustment for the angle of swing and depth or height of cut, and then you have the efficiency in terms of minutes per hour, and then you'll have the volume correction depending on whether you need it. Typically, you need it in bank units per hour. Sometimes, depending on the usage, if you are working in a quarry, for example, you will need it in unit of weight per hour. So you need in terms of ton per hour. So depending on what you need, you will play around with things. Okay. So for front shovels, these are the cycle times. So loading, swinging, dumping, and returning, swinging back again. These are the typical ranges for something of 3 to 5 cubic yards size shovels, which is very typical, by the way. However, there is an adjustment that should be applied in case of variation in the angle of swing and percentage of optimum depth. So the optimum depth, by the way, the optimum depth for a cut, you will see that the optimum depth is actually typically if you have a certain pre-specified optimum height. Actually, it's optimum height, not optimum depth of the excavation. You will notice that if you go beneath it or you go above it, you will get a lower productivity. So if I'm looking at 90 degrees angle and 100%, it's a 1. Anything below the 100% is less than 1. Anything above the 100% is less than 1. And again, the ideal is 90 degrees because typically this is the most common thing, that a truck will be placed at an angle of 90 degrees from the excavator. However, if it is placed at an angle less than 90 degrees, you'll find the job being faster because the swing time will be less. So you will factor it up. It's more than 1. If it is more than 90 degrees, you'll factor it down. Okay, because it's swinging a longer distance. So let's look at this example. A shovel with a 3 cubic yard heat capacity bucket is loading well blasted rock on a highway project. The average face height is expected to be 22 feet. The shovel has a maximum rated digging height of 30 feet. Most of the cut will require 140 degree swing of the shovel to load the whole units. What is the conservative production estimate in bank cubic yards? The size of the bucket is 3 cubic yards. The bucket fill factor from 100 to 110, so you use 100%, which is a conservative estimate. The cycle times, these are reasonably estimated depending on the case. Okay. However, if I was in his shoes, I would say, of course, this should be a larger range of cycle times because he's asking me to be conservative, but that was his decision. The average height of excavation is 22 feet. Typically, the optimum height is 50% of the maximum height that you could approach. So 50% of 30, this is 15 feet. So the percentage optimum height is actually 22 over 15. So this is 147. So if you apply linear interpolation, you'll find the swing factor from table 9.2 to be 0.73. The efficiency factor, typically the efficiency is ranging from 30 to 45 minutes per hour in such cases. So it's very conservative to say 30 minutes per hour. So in such a case, and since the well blasted rock will swell by 60%, from table 4.3 in chapter 4 that you have seen before. So we will plug these numbers into the equation, and we'll get 117 bank cubic yards per hour. However, for backhoes, there is another difference that you need to understand, which is that the safety issue is of a very high concern. So you need to check the safety that it could do the job first. So from this table, you could see the maximum digging depth, the maximum loading height, the maximum weight that it could carry, depending on the size of each backhoe. And based on that, it's very important to understand that you are not allowed to exceed 60% of the maximum digging depth. So if we look at the bucket size, of course, the larger is the bucket size, the more is the cycle time. This is making sense for sure. And for sure, loading, swinging, dumping, swinging, empty, this applies for all of them. However, you need to understand that, again, due to safety issues, you need to know for sure that you should not exceed 60% of the digging depth. And typically, if it is less than 30 or 40% of the maximum digging depth, this means that it is unsafe to, it's uneconomic to do the job. If you are exceeding 60%, it's unsafe. If it is less than 30 to 40%, it's uneconomic. So typically, you should maintain the range between 40 or 30 to 60% of the maximum digging depth. The swing angle is 30 to 60 degrees. This is because typically it's faster to do things between this range. Of course, if it is less than 30 degrees, there is a very high probability that the hauling unit will fall into the excavation itself. So it's unsafe to do it less than 30 degrees. If it is exceeding 60 degrees, again, that means that this thing could be somehow uneconomic to be done. So this is the optimum to have it within this range. So if I'm having such a case of 3.5 cubic yards bucket, doing an excavation in clay, and the loading height is 9 feet 9 inch in the hauling units, and the soil boring information indicates that below 8 feet the material changes to unacceptable silt material. What is the estimated production of the hoe in cubic yards bank measure if the efficiency factor is equal to 50 minute-hour? So simply the size of the bucket is 3.5 cubic yards. You should first check the range issue, that it could do the job. So it came that the 8 over 23 and 8 over 27, the 23 to 27, these are the ranges provided in the table. Both are more than 30 and less than 60 degrees, 60%. So that means that it is okay. Then you'll get your cycle times and sum them up from the table. The efficiency factor of 50 minute-hour. Hard clay will swell by 35%. You'll apply your equation, and you'll simply get a 300 bank cubic yard per hour for such a case. And for sure, this should have been earlier. You should check that the maximum loading height should be higher than the 9 feet 9 inch height of the hauling